Hey everybody, it's Mrs. C again, and my gosh, we're in the middle of doing linear functions in class, and I looked back and I realized I have no videos on graphing functions using what is called slope-intercept form, and that's just unacceptable. So I thought, a little early in the morning, I'm all ready to go, get ready to go to work. Why not just do a quick screencast to show you how easy it is to graph using slope-intercept form. So, but before I show you that, I just want to remind you of the method we've been using up to this time. So I have graph paper here. I don't really need graph paper, but it's nice lines, so let's go ahead. So say, for example, we had the function y is equal to 2x plus 5. That's a cute little function. And I asked you to graph that. Now, you'd be able to graph it, but for most of you, you would set up an XY table. So you'd get your domain, your range. You would come up with a couple values for your domain. That's your X values, say, for example, 0, 1, and 2. And then you would plug and chug, right? You would put in those values and you would get an output, or your y value, what we refer to as the range of the function. So let's just do that just for fun, just as a shout out to the old days. Let me use a different color here. I like to do this. It's kind of cool here, a little color coding here. We said 0, 1, and 2 for my x. Would have been nice if I had planned this a little ahead of time, but no worries. I'm doing it now. You're watching. You can always fast forward me if I am boring you. So let's go with a nice green. Okay, for my y values. So this is what I'm just trying to show you. For those of you who are still trying to figure out this whole plug and chug, put in the red, get a green. So I'm going to say 2 times 0 is 0. 0 plus 5 is 5. So my y is equal to 5. So my range value is a 5. When x is 0, y is 5. So let's just go ahead, do it again. This time I'm going to input a 1, and we'll just change that and erase this. How about that? So I'm going to change this to a 1, and then that's going to give me 2 times 1 is 2 plus 5. That's going to give me 7, so I have my y equal to a 7. So I'll change my color. I'll put a 7. When x is 1, y is 7. And last but not least, I'm going to go ahead and I'm going to input 2. Now you can do it in your head. I know you're looking there going, why are you showing the process? Well, I'm showing the process for the people that aren't completely sure of what I'm doing. And I also show process so that I don't screw up, because sometimes my head doesn't work as well as I would like it to. So there, I was talking and writing at the same time. Let's see if I did that right. 2 times 2, because x is 2. 2 times 2 is 4 plus 5 is 9. I agree, except I'm supposed to change to the nice color of green. Okay, these are my values. I've got 0, 5, 1, 7, and 2, 9. So let's plot those. 0, 5, 1, 7, 2, 9. Well, here's my nice little coordinate plane. I said 0, 5, so 0 on the x and up 5. 1, 2, 3, 4, 5. That's about, sorry about this, hang on. Up. Sorry, having mechanical difficulties. 1, 2, 3, 4, 5. You can't see what's going on, but I can. All right, that's not the best point, but it's the best you can do on a whiteboard, digital whiteboard, I guess. All right, what was the other one? I've already forgotten. It's a 1, 7. So 1 and 5, 6, 7. I believe I'm there. Every time I hold too long, it makes a little lasso. Okay, and then the last one, do you remember? It was 2, 9. All right, so 2, 9. Oh my gosh. I don't have room for a 2, 9. And this is the best part. This is exactly why things like this happen. And we need to be able to figure out, what am I supposed to do? So right now, for the fun of it, because I know I would have told you to go back, put a different point in, and go ahead, plug and chug, and maybe pick a negative, maybe something downward, because I can't go any further up. But right now I'm just going to connect these in a nice, hopefully nice looking line. Is not the easiest thing to do. Put my little arrows. Sorry, I can't get any closer to the end. Put my little arrows. Ba-da, ba-da, ba-ba-ba. Yes. Now that's just using a table of values, right? But that's a lot of work, and we don't have to graph that way. Here's the deal. I want you to look at this one more time. Da, 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 da. My nice little function is in what is called slope-intercept form. Now, we've done a little bit of this in class, but I just want to break it down for you. It's in slope-intercept form when it is in this y equals. So if your y is by itself, everything else on the other side, once it's simplified, will be your slope-intercept form. We like to put the, what do I always tell you, the x term in front and the constant, the number, in the back. So it would go y equals your x term plus your constant. I can't fit any more there. So your x term meaning the number and the letter x, and then the constant meaning the number that has no variable with the y by itself on the other side. Now here's the fun part. When you're in this form, this x, not this coefficient of the x, excuse me, for example, in this case, the 2. The coefficient of the x is your slope, and your constant, which is this one, is your y-intercept. So when you're in this form, one more time, the coefficient of your x is your slope, and your constant is your y-intercept. Let's write that down. Okay. So when you're in y equals form, and you can go ahead and write it. You don't need to wait for me. Oh, what the heck. Let's just do this. Okay. When you're in the form, y equals some letter, some number, it doesn't matter. Let's pick an A. X plus B. All right, when you're in this form, and the A just takes over for the coefficient. Let's write that. Coefficient. And the B takes over the constant's place. Constant. When you're in this form and the y is by itself, the coefficient of x is your slope, and your constant is your y-intercept. Ooh, you get those in your notes. How beautiful is that? So I'll say it one more time. It's that important. The coefficient of your x, in this case the a, is your slope value. And the constant, in this case the number that's completely by itself, and it's the b, is your y-intercept. So let's take a look at this line. Do you remember it was y equals 2x plus 5. So one more time, the slope is 2. Remember the coefficient of the x. And the y-intercept is 5. So what do those things mean? Well, it means that my line will cross the y. That's what a y-intercept is. It's where the line hits the y-axis. And in this case, take a look at it. This line hit the y-axis right there. And if you count up, 1, 2, 3, 4, 5, it's hitting at the 5 on the y, otherwise known as the 0, 5 ordered pair. Now, the slope is what you rise and run, the ratio of your rise to run. In the case of a whole number, and let me just get rid of this for a minute, you've done slope before, but in the case of a whole number, you don't see a ratio because there is no denominator in a whole number, so just put it there for a minute. Any number can be expressed as a number over 1. So in the case of 2, you could say 2 over 1. That's the rise to the run ratio. So one more time, rise over run. equals 2 over 1. And so that's telling me that from the point that I hit the y, or from any point on this line actually, if I rise 2 and run 1, and that's in one step, rise 2, run 1, rise 2, run 1, I will hit another part of the line. Conversely, I could also rise -2, run -1, because aren't those equivalent? Isn't a -2 over a -1 equal to +2 over +1? Of course they are. Negative over a negative is ultimately positive. And so you can express it either way. Why would I want to do that, Mrs. C? Well, because look up at my graph. Remember the last point that I had, this one? Remember the problem was that I couldn't go pretty much any higher. I think I had to go to 9. I can't get to, well, was it 2, 9, 9, 2? I can't go up 9, or I can't go up to the 9 because it's off of my screen at least. I know sometimes you see something a little different. I have to be able to mambo out of that problem and go in a different direction. So let's take a look at this last point, the point below, not the last point, but this point. I said that the slope, if I do my rise-run combo from any point along the line, I'll hit another point on the line, and let me show you that. If I rise a -2, because I don't want to go up, I want to go down. So let me rise a -2, that's a drop of 2, and let me run a -1, which is a run towards the negatives instead of the positives. That's all that bottom number sign tells me. The top sign tells me up, down. The bottom sign tells me left, right. So if I go down 2, 1, 2, I need to run to the left 2 places from here, 1, 2. Now, that is showing me that I did a poor job doing my 1, 2, 1. Oh, I wasn't supposed to go. No, that's showing me I'm not thinking in the morning. I'm supposed to do down 2 over how many? I hear ya. I know, I wasn't thinking. I was just having too much fun. 1, 2 over 1. There we go. See how I hit the line? Now, let me get rid of those lines. I hit it here. Let me drop 2 and run 1 again. 1, 2, 1. I hit it again. Do it from here. 1, 2, 1. I hit it again. Now, I don't usually do these wiggly whoops, but I'm doing that so that you can see what I'm doing. That's the only reason why I'm showing you this very confusing craziness. All right, let's try it again, guys. I know you got me. Some of you are like, please, I already know how to do this. And others are like, what the heck are you doing? Because you never learned it. So I got to kind of talk to all of you, right? Now, I want to finish up because I read a study that said don't do videos longer than 10 to 12 minutes, and I'm already over that number, so I've got to hurry up. Let me do y equals -3x minus 6. All right, do you remember which one's your slope, which one's your constant, or your y-intercept? Slope is the one touching the x, so let's write it over here. Slope, what's that going to be? What's my slope? My slope's going to be a -3. What's my y-intercept then? That's right, my y-intercept is a -6. Now, you always want to start with where you hit the line. We're trying to draw a line on the graph. If we know where we hit the y-intercept, or the axis, then put the point there so that you can start from some place. So let me go back to, let me do black here. So I want to put a point where? At my y-intercept, which is -6. 1, 2, 3, 4, 5, 6. Now I know I always tell you don't do the little hash marks, but I want you to see what I was doing. That's why I did it. Okay, so I have my point at -6, and from there I want my slope. I need to know my line is going to hit every what combo move? Well, my rise is -1, my run is +1, because any number expressed as a whole number is that number over 1. And so what are my two slopes? Well, my slope could be, I'm going to write it again here. My slope, where's the E? Slope is a -3 over 1. But what's my other option? I could say my slope, there's always two. It's the same slope, but there's two equivalents. A 3 over negative 1. What? Well, 3 over negative 1 is a negative 3, right? That's my slope. But so is negative 3 over 1. That's a negative 3, and that's my slope. And I want to be able to do that so that I can go up and down from this point. Okay, so here's my starting point. I'm going to go down 3 and over to the positives 1. So go down 3, 1, 2, 3, and then over 1. That will be right there. Let me get rid of that. Right there. Now let's reverse. We did this one, right? Let's do this one over here. Up 3 to the left 1. So from this point again, I like to go from my original 1, 2, 3, and then over 1 that way. It is not easy to make a point on a whiteboard like this. Okay, there's my line. Now I get my cool tool here, draw my line. Not easy to do. That was not good. This is the hardest part on a computer, to get those to line up. Okay, ish. Now I'm going to show you why I mean ish, because really, remember up 3 over 1, I should hit the line again. We'll take a look at this beauty. If I go up 3 from this point, 1, 2, 3, I really should be hitting there. 1, 2, 3, and then I should be hitting there. And that's you clearly not happening so much. Wait, this looks wrong. Did I do this wrong? This looks off here a little bit. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 1. 1, 2, 3, 1. I see it. See how those didn't line up? I don't know if you see it, but I see it. Maybe I can zoom in. Yes, I can. Right there. That was not a good thing right there. Because when I go up 3, watch. 1, 2, 3, over 1. I miscounted. So I'm sorry if I confused anybody, but you're going to see I caught myself. I caught myself. Or did I catch myself? I think I caught myself. 1, 2. Yep, I'm good. 1, 2, 3. You guys will let me know in the morning if I do this wrong, won't you? All right. All right, that's just a tiny little lesson. Sorry it went a little bit over my time constraint. But this is a nice little lesson on how to graph using slope-intercept form. There will be more videos to come. Until then, guys, peace out, and I'll see you on the flip side. Later.